All right, we're going to look at properties of radicals now. We just spent a little bit of time looking at the properties of rational exponents. When we have radicals, as long as we have the same index, okay, so if we're taking a radicand that's to an index times another radicand to the same index, the key is that the index is the same. We can just multiply these radicands together and put them under the same radical sign, which is what we just did with the rational exponents, okay? We can multiply the a times the b and raise it to the same, as long as it's the same index, so the n is the same value. Same thing with the quotient property of radicals. If we're dividing values, we can break this up with the index and take the nth root of a and divide it by the nth root of b. Or we can, if this divides, we can just go ahead and divide it and then take the root of it. So let's see what that looks like with actual radicals. So since we're looking at the cubed root of 12 times the cubed root of 18, we're multiplying, so we can just take these two radicands and we can multiply those together. We're going to say 12 times 18. Now, rather than multiplying 12 times 18 and getting a larger number, which then we're going to have to turn around and break down into factors to see if anything comes out from underneath the radical, I'm going to leave this as these two factors and I'm going to break these down individually. 12 is 3 times 4. 3 is prime, and 4 is 2 times 2. Okay, 18 is going to be 2 times 9. Okay, so the 2 is going to come down, and 9 is 3 times 3. So I'm looking for cubed root, so I'm looking for 3 of the same. I've got 3 3's here. I'm sorry, I have 3 2's here, and I also have 3 3's here as well. So a 3 is going to come out, and a 2 is going to come out, or 6. If I would have multiplied 12 times 18, I'm going to say I would have gotten 216 out of that, and the cubed root of 216 comes out to be 6. When we're dividing, since the index, the root is the same, they're both fourth roots, I can combine those if it's easier for me and just do 80 divided by 5. And since 80 does divide by 5, that's what I want to do in this situation. So 80 divided by 5 is 16. And now we're just finding the fourth root of 16. Well, 16 is 4 times 4. And each of these 4's is going to break down into 2 times 2. So I have 4 2's. Okay, since the index, they're both fifth roots here, the index is the same, I can go ahead and I can multiply 16 times 8. That's the fifth root of, now rather than taking 16 times 8 and getting a larger number that I have to then in turn start factoring to see if anything comes out from underneath the radical, I'm going to break this down. I know that 16 is 4 times 4, and each one of those is going to be 2 times 2. And then I can break 8 down into 4 times 2. So that 4 is going to be 2 times 2. So I need 5 2's. 1, 2, 3, 4, 5. There are 5 2's there. So a 2 is going to come out. And then these two 2's don't get circled, so they're going to have to stay underneath the radical. I'm going to multiply them back together and get 4. And it's still the fifth root. Don't change your index. Since these are fifth roots, my answer has a fifth root in it. Okay, I'm asking you to take the cubed root of 135 here, so we're just going to break that down into factors. 5 times what is 135? That would be 27, I believe. Okay, so 5 is prime. 27 is going to break down into 3 times 3 times 3. I'm going to skip the 3 times 9 because I know by now that 27 is 3 3's, and I'm looking for cubed root, so those 3's are going to come out, and the 5 has to stay under, and since it's a third root, it's still going to be a third root. Okay, now, these last two. This doesn't help me. Like up here, I wanted to put the 80 and divide it by 5 because 80 did divide by 5. In this case, if I put these together and I say I want the fifth root of 7 divided by 8, well, this doesn't help me because 7 doesn't divide by 8. There's nothing that simplifies into. So in this situation, I'm not going to put that together and try to divide. Instead, what I'm going to do is, we can never leave a radical in the bottom of a fraction. You have to simplify that. So if I were to break this down, 8 is 4 times 2, and 4 is 2 times 2 times 2. So when we have the fifth root of 8 here, what we have is we have 3 2's. well, how many more 2's do I need in order to be able to take the fifth root of them and bring it out from the radical, underneath the radical? Well, we need a total of 5 2's because we're taking the fifth root. I have 3 of them. So I'm going to multiply this by the fifth root. Okay, the index has to be the same, so I'm going to use the fifth root. But I need 2 more 2's. So I'm going to use 4. 4 is 2 more 2's. And whatever I do to the bottom of a fraction, I have to do the exact same thing to the top of the fraction so that it will stay equal. So when I multiply these together, go back up and use your rule up here. When I multiply here, I'm going to get the fifth root of 28 over the fifth root of 32. Well, the fifth root of 32, how many 2's is that going to be? 8 was 3, and this is another 2, so this is a total of 5 2's now. Okay, so those are going to be circled and come out. So this is going to be the fifth root of 28 over 2. I cannot divide the 28 and the 2 because the 28's under a radical and the 2 is not. So we cannot simplify there. This is my answer. Okay, when I'm looking up here, I'm taking the fifth root of 3/4. 3 doesn't divide by 4, so I'm going to break that up and say that's the fifth root of 3 divided by the fifth root of 4. Okay, we know that 4 is 2 times 2. There are 2 2's here. In order to simplify and bring out so that there's no more radical, I need a total of 5 2's. So I'm going to take this times the fifth root. I need 3 more. So 2 times 2 times 2, well, that would be 8. Okay, I'm going to multiply whatever I do to the bottom of a fraction. Got to do the exact same thing to the top of the fraction. Okay, now see what we have. We've got the fifth root of 24 in the numerator. 3 times 8 is 24. And I've got the fifth root of 32 in the denominator. Fifth root of 24 doesn't simplify. That would be 8 times 3. That would be 3 2's and a 3. That's not going to be 5 of anything. But the fifth root of 32 simplifies into a 2. Now we can leave a radical in the numerator of the fraction. We just can't leave it in the denominator. So this would be considered my simplified answer. Okay, and then at the bottom of your notes, just we've kind of done some like this before. So this is just kind of a review. Third root of 64, we are going to be breaking this down into 8 times 8. Okay, 8 would be 2 times 2 times 2, and this 8 was going to give me 2 times 2 times 2. So I'm looking for groups of 3. So 2 2's are going to come out, that's 4. And then we take the exponent divided by the index. So this is going to be y to the second. Okay, this is a rational exponent form. This was a radical, but this is in rational exponent form. So I'm just going to kind of distribute that power. That's 27 to the 1/3 power. Think about what that means. 27 to the 1/3 power means the cubed root of 27. Okay, so that's going to equal 3. And then when I multiply my exponents here, you're going to take 1/3 times 3. That's 1. And 1/3 times 12 over 1. That's going to be 12 over 3, which is 4. That's going to be q to the 4th. Okay, we're back to a radical form here, and we're just going to divide. So we're going to say that is m to the first, the exponent divided by the index, and here's the exponent divided by the index. That's going to be n to the second. And no radical ends up being in my denominator, so I'm done with that. All right, go ahead and give worksheet 5-2C a shot.